दृष्टुं ज्वलन्तं सर्वतोमुखं नृसिंहं भीषणं भद्रं मृत्युं नमाम्यहम्. Dear students, I welcome all of you to the classes we are studying in the basic concept of the chemistry. Today we are going to study what is Avogadro's law. So Avogadro's law was proposed in the year 1811. Avogadro was the scientist, I can say the pioneer in chemistry, who introduced the concept of molecule. Before Avogadro, the word molecule was not there. It was known when atoms combine, they form a compound atom. The compound atom word itself looks complicated. Compound atom. Atom is responsible for all physical and chemical properties, exhibits elementary properties, but a compound does not have the elementary properties. The moment you use a word atom to compound atom, if you say, then it loses its meaning, it loses its importance. So he introduced the concept of molecule. He say when atoms of the elements combine, they produce a particle, a smallest particle which has free existence is called as molecule. And atoms of same element combine to form homoatomic molecule, and atoms of different element combine in definite proportion to form a molecule of a compound. So then he proposed a hypothesis. This Avogadro's law, this came, he did not propose it as a law, he proposed as a hypothesis, and which became a law itself. Then what is that hypothesis? Before I explain you the word law, it came as a hypothesis. So this hypothesis is a compound word. Thesis is one word, hypo is one word, two words they join, they explain a phenomenon. Hypo means imaginary. Then thesis means an independent explanation of a phenomenon. When somebody proposes an independent explanation which was not proposed earlier, but the first time he is explaining according to his knowledge, then that is called as a thesis. For example, I have submitted my thesis on the university and awarded the PhD degree. I do research, I conduct experiment, I get my observations, then I put all the observations and I got a conclusion. I wrote everything and in the form of a book and submitted to the university. That is examined by the examiners, and they say it is an independent explanation of the event of a phenomenon, and they award me the degree, doctorate degree. So that is thesis, hypothesis. And this hypothesis means an imaginary one. It is an imaginary explanation of an event or a phenomenon. And this phenomenon, when this is generalized, this becomes theory. This becomes theory. If that hypothesis is applied to one and all and found correct, then that get a status that is called theory. When this theory is experimentally verified or mathematically proved, if it is experimentally verified or mathematically proved, then this becomes a law. And the law is a truth. Law may have an exception to the law. Some exceptions may be there, but it is a truth because it is mathematically proved or experimentally verified. But beyond a hypothesis, there is no experiment. Only it is just a thinking. It comes as thesis. So Avogadro proposed a hypothesis. When we were students in the 1966 reading intermediate science, which was now called +2, we read it Avogadro's hypothesis. When I became a lecturer in 1973, I taught it in hypothesis. By the time I became principal, then books printed it as a law, because the applications of Avogadro's hypothesis were experimentally proved, were mathematically found correct, and there is no substitute to that it. So instead of the word hypothesis, they proposed that a law. So the hypothesis of Avogadro became law itself because of its valuable application in many scientific explanations. So what the law says? The law states that equal volume of all gases, equal volume of all gases under similar conditions of temperature and pressure. Similar conditions of temperature and pressure contain equal number of molecules. Equal volume of all gases under similar conditions of temperature measure. That means if you keep the pressure and temperature constant and take same volume, the number of molecules present in A will be equal to the number of molecules present in B. For example, if you take 100 cc of hydrogen, 100 cc of nitrogen, 100 cc of carbon dioxide, then the number of molecules of hydrogen present in 100 cc will be equal to the number of molecules present in nitrogen, the number of molecules present in 100 cc of carbon dioxide. Because carbon dioxide is a big molecule, 3 atoms are there. In hydrogen 2 atoms are there, and nitrogen 2 atoms are there, and hydrogen atom is the smallest atom. But if you can find the molecules will be same. So this is the hypothesis proposed, which became a law. So this is a very important law which has wonderful applications, and those wonderful applications explain the molecular mass, the vapor density, gram molar volume, many aspects this law found. So what are the important applications of this Avogadro's law? So the important applications of Avogadro's law are: 1, to find out atomicity of gas molecules. Atomicity means number of atoms present in a molecule of a gas. Number of atoms present in a molecule of a gas is called as its atomicity. So what he found out? He found out all elementary gas molecules are diatomic. He proved it. Logically he proved it from the definition of atom, from the definition of molecule. He proved that all elementary gas molecules are diatomic. The hydrogen element molecule contains 2 atoms, the nitrogen molecule contains 2 atoms, oxygen molecule contains 2 atoms, fluorine molecule contains 2 atoms, then chlorine molecule contains 2 atoms, bromine molecule contains 2 atoms, and iodine molecule contains 2 atoms. All these are elements they exist in gaseous state and their atoms, their molecules are diatomic. It's a wonderful finding of Avogadro which was proved by him. Then second comes to establish a relationship between molecular mass and relative density. So he found a relationship between the molecular mass of a gas and its relative density. The relative density is otherwise called also vapor density. It is otherwise called as vapor density. So he established relationship between the molecular mass and vapor density. So what are the relationship he found out? He found out that the molecular mass, he found out this relationship, molecular mass of any gas, molecular mass of any gas is 2 into relative density or vapor density. Relative density or vapor density. We will be reading this. We will define relative density or vapor density and we will establish the relationship between them, how we got it. Then third important application to find out gram molar volume, that is known as GMV of any gas at NTP. NTP means normal temperature and pressure. Read in school, normal temperature and pressure. 1 atmospheric pressure minus 273 degrees centigrade absolute, the 0 degree absolute, and that is called as normal temperature and that is called as normal pressure. So when the temperature is normal, 0 degree absolute, that is minus 273 degrees centigrade, and the pressure is 760 mm or 76 centimeter, then what would be the gram molar volume? So he proved that the gram molar volume, the gram molar volume of all gases at NTP is a constant, equal to 22.414 liters. He found out the gram molar volume of all gases at NTP is a constant and equal to 22.414. Means you will think small gas, hydrogen molecules are very small, nitrogen molecule little bigger, oxygen little bigger, but if you go to carbon dioxide, it's a very big molecule. But if you take gram molar volume, what is a gram molar volume? The volume occupied by 1 gram molecular mass of any gas is called gram molar volume. The volume occupied by 1 gram molecular mass of any gas is called gram molar volume, and that gram molar volume of the gas, any gas at NTP is a constant. This is a very important application which gave the importance to Avogadro law, because this led to find out many relationships and establish the mole concept. All this could be done by this. Then comes the next very important application was to find out the molecular formula of a gas. To find out the molecular formula of a gas from Avogadro's law. He used Avogadro's law, his hypothesis, and established the formula of this. For example, ozone. Ozone is a gas. 3 atoms of oxygen combine to form ozone. He proved the molecular formula of ozone is O3. He also proved the molecular formula of ammonia. From his law, he proved the molecular formula of ammonia is NH3. He proved molecular formula of hydrochloric acid gas is HCl. So all these things he could prove this. Why it was so important? Because think, it was 1811 when Avogadro proposed his law. In 1827 the electricity was discovered. Electricity was also not there. Forget about other things. So no instruments, very normal instruments must be there in the laboratory. Only thinking to see the invisible eye. He will see the invisible eye. Their eyes were thinking, they think and see those which are invisible. So they are speculating. They have a penetrating vision. So that is by using Hughes' hypothesis, he established the molecular formula of ozone. He established the molecule of ammonia. He established molecule of HCl, and there is no way out for the world of science to accept Avogadro as one of the genius scientists of the time. Then to find out the density of a gas at NTP. Density of a gas at NTP. By applying his law or from his applications, he could determine what will be the density of oxygen at NTP, what is the density of oxygen, nitrogen, carbon dioxide. And during that time what has happened? Boyle's law was discovered, Charles' law was discovered, combined gas law equation was known, ideal gas equation was known. The moment he found out the relations of a density, then at any temperature and pressure, the density was found out by the application of combined gas law equation. So these are the important findings or applications of Avogadro's law. I would like to now teach you first a very important application to relationship between molecular mass and vapor density. So according to Avogadro proved that the molecular mass of a gas is twice vapor density. Now we are going to establish relationship between molecular mass and vapor density or relative density. Vapor density is relative density. So let me define first molecular mass, then let me define vapor density, then we will take the Avogadro's law and establish a relationship. So I am going to definition of molecular mass. What is molecular mass? The molecular mass is a relative mass. A relative mass is defined as a ratio of the mass of a molecule of a substance to the mass of an atom of hydrogen. I am not going to 1/12 parts up because this was the definition given in the year 1961 In which year we are now? We are here now in the year 1811. We are 1811 and studying this. We are going back to 1811 and studying this. Today, the molecular mass is defined as a ratio of the mass of a molecule of the substance by 1/12 parts of the mass of an atom of carbon. But at that time, what was the definition? How many times a molecule of a substance is heavier than one atom of hydrogen? So molecular mass, we'll first define molecular mass and write the definition of the vapor density. Then we will find out a relationship between this. So the molecular mass is a relative mass. It is a relative mass. Mass is defined as a ratio of mass of a molecule of the substance to mass of an atom of hydrogen. This is the definition. So substance, why? Because I told you already, it may be a molecule of an element, elementary molecule, or it may be a molecule of a compound. So hence I am using the word here substance. And what is the relationship? Molecular mass is equal to a ratio of what? The mass of a molecule of the substance to mass of an atom of hydrogen. So let us put this as equation 1. Let us put this as equation 1. The molecular mass is equal to what? Molecular mass of the substance by the mass of an atom of hydrogen. Then we will write the definition of relative density and vapor density and find out how to get the relationship in them. The vapor density, we will now write the definition. Vapor density or relative density. The same vapor density is relative density is defined as the ratio of mass of certain volume of gas or vapor to the mass of equal volume of hydrogen under similar conditions of temperature and pressure. So I can write it in an abbreviated form: under similar conditions of temperature and pressure, USCTP. I am writing that as a USCTP. The vapor density or relative density is defined as the ratio of mass of certain volume of gas or vapor to mass of equal volume of hydrogen under similar conditions of temperature and pressure. That means if you want to determine the relative density of hydrogen, you take 1 liter of hydrogen, write its weight, and relative 1 liter of hydrogen. But if you want some of the oxygen, relative density, mass of 1 liter of oxygen by mass of 1 liter of hydrogen, when they are under similar conditions of temperature and pressure, that ratio will become the vapor density. So then what is vapor density? So vapor density is equal to a ratio of the mass of certain volume of gas or vapor to mass of equal volume of hydrogen. When both are, here I am writing, when both are under similar conditions of temperature and pressure. When both are under similar conditions of temperature and pressure. So you see the vapor density is defined as a ratio of mass of certain volume of gas or vapor to mass of equal volume of hydrogen when both are under similar conditions of temperature and pressure. Let this be our equation 2. Now we will find out relationship between equation 2 and equation 1. That will be our relationship between molecular mass and vapor density. So mass of certain volume of gas or vapor, volume. So volume. So what we will do, we will apply the Avogadro's law. We'll assuming the Avogadro's law to be correct. We will assume the Avogadro's law to be, because we are applying Avogadro's law. So then we'll apply the Avogadro's law and find out the relationship between equation 1 and equation 2. Let the certain volume of hydrogen contain n molecules. So under similar conditions of temperature and pressure, under similar conditions of temperature and pressure, equal volume of the gas will also contain n molecules as per the Avogadro's law. As per the Avogadro's law. Why? The equal volume of all gases under similar conditions of temperature and pressure contain equal number of molecules. Now we will go to the equation 2. So from equation 2, if we put the n molecules, so vapor density will be equal to what? Mass of n molecules of gas by mass of n molecules of hydrogen. Why? According to Avogadro's law, mass of certain volume contain n molecules, same volume will contain n molecules. So now n will cancel. Therefore, this comes as what? Vapor density will be equal to mass of one molecule of gas by mass of one molecule of hydrogen. mass of 1 molecule of gas by mass of 1 molecule of hydrogen. But according to Avogadro's law, what is hydrogen? Hydrogen is an elementary gas, and all elementary gas molecules have 2 atoms. So according to Avogadro's law, hydrogen, an elementary gas, hydrogen is an elementary gas, hence the molecule is diatomic. The molecule is diatomic. Since hydrogen is elementary gas, its molecule will be diatomic. That means what? The hydrogen molecule is H2. Now therefore, from this equation then what will happen? So the mass of 1 molecule of the gas by mass of 1 molecule of hydrogen. So this 1 molecule of hydrogen contain how many atoms? 2 atoms. Therefore we say, therefore vapor density will be equal to what? Mass of 1 molecule of gas, mass of 1 molecule of gas by 2 into mass of 1 atom of hydrogen. Why? Hydrogen molecule contains 2 atoms. Therefore, 1 molecule of hydrogen contains 2 atoms. So we write 2 mass of 1. Now the mass of 1 molecule of gas by mass of 1 atom of hydrogen, this one is what? Molecular mass. So by definition, mass of 1 molecule of gas by mass of 1 atom of hydrogen is what? Molecular mass. As per equation 1, mass of 1 molecule of gas, so this is molecular mass. Therefore what will happen? Vapor density will be what? Molecular mass. This is molecular mass by 2, or you say molecular mass was 2 into vapor density. This was a very important application that Avogadro found out from his law. He has not taken up help of any other application. From his law he proved the molecular mass is 2 into vapor density. So wonderful application. Next class, children, we will go for gram molar volume of any gas at NTP is a constant 22.4 liters. Thank you very much.